All right, ladies and gentlemen, we're moving on to example 4. Here we're talking about, you got a bag, it has 20 $1 bills and 5 $100 bills. You randomly draw a bill from the bag. In other words, you're just going to reach in and you're going to grab something. What is the chance that you find the first bill is $100? And what is the chance the second bill is $100? Now, the thing we got to realize here is these are dependent events. When you reach in and you grab a bill out, unless you're specifically told to, we're not putting it back in. At least that's the assumption, because it says draw another bill from the bag. Actually, it does say, I guess, set aside. See, even sometimes I overlook stuff. Because it says you set it aside, you did not put it back in the bag, so it's no longer in the bag to pull out from that first one. So the chance of pulling a $100 bill the first time is 5 out of the total bills. Well, 20 plus 5 is 25. So I have a 1 in 5 chance of pulling a $100 bill. The thing is, there's now, theoretically, one less $100 bill. As a matter of fact, I know for a fact there's one less bill altogether because I set one aside. But what we're going to do is we're going to assume the probability of A occurred. So that means I'm actually going to be placing 4 instead of 5 in the numerator because the number of 100s left is potentially 4. Just like if it was, if it had said what's the second bill is $1, we wouldn't have said 20, we would have said 19. We would have taken away from that. So, nope, hold on, correction. We wouldn't have taken, if the probability of A is $100, then we wouldn't have taken away from the $1 stack. We would have taken away from the 100 because it's the difference if A occurred and did occur. All right, sorry, good correction on myself. I had to think about it for a second. My brain gets jumbled when it gets to this, so I can't imagine y'all's. All right, so to go over this again, we're only subtracting 1 from the numerator if the probability of B is the same pool as the probability of A. In other words, they were both $100 bills. If probability of B had been a different pool, in other words, if the probability of A was based on a $100 bill and the probability of B was based on a dollar bill, we would not take from the numerator, we would only take from the denominator. All right, now with that said, I did my Zoom thing again. I have 4 over 24, which is 1 over 6. Now, we have P of A for dependent events is the same thing as the probability of A, which we've already said is 1/5, times the probability of B after the probability of A, which we have said is 1/6. And that is going to be 1 over 30, which I've got that written here. Hold on. 0.033, or we have a 3.3% chance or probability we will pull a $100 bill in the first random pull and a $100 bill in the second random.